Assalamu alaikum everyone. Assalamu alaikum everyone. Can you hear me?
Yes, ma'am.
Okay.
Yes, miss.
Students. Okay. So good afternoon everyone. How are you all? Hope everyone is good. So let's start our today's
I'm fine,
lesson.
miss. How are you?
I am good, alhamdulillah. Yes. Okay. So a small reminder to everyone that you have to rename your Zoom. There is an option from which you can rename your Zoom, because I cannot see your pictures. Also, I don't know which student is which one. Okay. So if you can rename, I can just identify you with your name. So I don't think so there is any Amara student. There is Aisha, Fajr, Fatima, and Rehma. I can identify them. Amara is someone. Uh, Amara, what is your name? Can you
Miss, my
unmute your?
mother's name is Amara. I am Harim.
You are Harim. So Harim, you have to rename your Zoom. It is very easy to rename. Okay, rename and
Okay,
write
miss.
your own name, Harim. Okay, that will
Okay.
help me to identify you. Thank you so much. Okay, so we are starting. So what are whole numbers today?
Miss,
Yes.
miss, I couldn't understand question number 9 you gave in the homework.
Okay. We will do it. We will do it in the last 10 minutes. Okay.
Miss, your
So first
voice
of
is
all,
not clear.
okay, now I'm going to speak. I'm going to start the lecture. You can mute your mic, and if you have any question, then you can unmute it. Okay.
Okay.
You people can keep your mics mute. If you have any question, then in that case you can unmute your mics. Okay. So there are a few new students too, so we need to help them organize their lesson too. Okay, so we have to start from whole numbers. So what are whole numbers? For example, 0, 1, 2, 3, 4. These are the numbers starting from 0 and moving on in the positive direction are called whole numbers. Whole numbers start from 0 and move on in the positive direction up till infinity, that are called whole numbers. So whole numbers are divided into two big categories. One category is called even numbers and one category is called odd numbers. So what are even numbers? We have the numbers that are divisible by 2. Divisible by 2 are called even numbers. Numbers which are not divisible by 2 are called odd numbers. So from the whole numbers category, we have 2, 4, 6, 8. All of these numbers are even numbers. Then 1, 3, 5, 7, which cannot be divided by 2, are called whole numbers. Now after this, coming to factors. One more student is in the okay. So now coming to factors. What are factors? So let's suppose I have a number 18. How many factors does number 18 have? So 18 can have factor, 18 can come in the table of 1. So every number come in the table of 1. So 1 is a factor of every number. So 1 times 18. We can write 18 as a product of two numbers. It is 1 and 18. So 1, we can write 18 as product of two numbers, 1 and 18. So 1 and 18 are the factors of 18. So we can also write 18 as a product of two numbers, 2 into 9. So 2 and 9 are again the factors of 18. We can write 18 as a product of two numbers, for example, 6 times 3. So 6 and 3 are the factors of 18. So how many factors do 18 have? 1, 2, 3, 6, 9, 18, the number itself. So these are all the factors of 18, means all in these, the 18 is divisible by all of these numbers. Okay. So now, is 18 divisible by each of these factors? So yes, because factors are those numbers with which the number is divisible by 100%. So we can also find out the factors of 18 in this form. This is called prime factorization. So we can do 2 times 9 is 18, 3 times 3 is 9, 3 times 1 is 3. So product these three numbers and the product of all these numbers will be the factors of 18. For example, 1 is a factor of every number, so 1. 18, the number itself is factor of every number, so 18. Then comes 2, then comes 3. Then 2 times 3 is 6. Then 3 times 3 is 9. So the numbers that come in this factor tree and the product of those numbers all are the factors of the 18. Okay. Now we will struggle a bit to find the factors of a few numbers because we really want to realize about how the factors carry on. Okay. So now I will write 1, the number 1. How many factors 1 have? 1 is divisible by only one number, that is 1. So 1 has only one factor, that is 1. Okay. 2, 3, 4, 5, 6, 7, 8. Okay, factors of 2. What are the factors of 2? 2 is divisible by 1 and 2. 3 is divisible by 1, 2, 3, right? 4 is divisible by 1, 2, 4. 5 is divisible by 1 and 5. 6 with 1, 2, 3, then 6. 7 with 1, 7. 8, 1, 2, 4, 8. Okay, coming to the next numbers. 9, 10, 11, 12, 13, 14, 15. Let's complete up to 15. Okay, 9. Now each one of you are going to tell me one by one the factors. Okay, so first of all, I'm going to ask Aisha. Yes, Aisha. Can you tell me the factors of 9?
3, 1, 3,
1, then
1, 3,
very good.
9.
9, good. Okay, next is Hareem. Yes, Hareem, can you tell me the factors of 10?
1, 2, 5, and 10.
Very good, Hareem. Okay, next is Fajr. Can you tell me the factors of 11? Fajr. Fajr has a first lesson today. Yes, Fajr.
Factors of 11 are 1 and 11.
Very good, Fajr. 12. Fatima. Can you tell me Fatima? Yes, Fatima. Fatima, can you tell me the factors of 12? Can you hear me?
1 and
Okay, 1 and
4,
first 1, 2, then 2
3,
times 6 is 12. 3 times 4 is 12. Okay, 4 times 3 is 12. Okay, next.
and 12.
6. 2 times 9. 6. 2 times 6 is 12. So 6 is also factor. 7 is divisible by 12. No. 8, 9, 10, 11, and now it comes to 12. Okay, Fatima. Tell me the factors of 13 now. Yes, Fatima? Fatima, you're taking too long. Okay,
Your
Zen.
voice is not clear.
Okay, Zen. Tell me factors of 13.
Miss, 13 is a prime number, so it will be 1 and 13.
Very good. Zen, can you tell me 14 too?
14 is composite. It has 1, 2, 7, and 14.
Fajr, can you tell me 15?
15 is a composite number. It has 1, 3, 5, and 15.
Okay. So now as we have to find out the factors of all of the following numbers, we are going to see which of the following numbers have only two factors. The numbers that have only two factors are called 1 and
Prime
itself.
numbers.
Prime numbers. The prime number is a whole number that has exactly two factors, 1 and itself. So let's find all the prime numbers. 2, 5, 7, 11, 13. So the numbers which have more than two factors are called composite numbers. So I have marked with purple box, I have marked the prime numbers. Now I'm taking another color. I will take brown color and I'm going to mark the numbers which have more than two factors, and they will be composite numbers. There are 3, 4, 6, 8, 9, 10, 12, 14, 15. So can you see there are a few prime numbers and a few composite numbers, but there is one number left, 1, and no one is talking about 1. So there is also also a whole number. Whole number starts from 0, not 1. Whole number starts from 0, not 1. So there are two numbers. One is 0 and one is 1. What about these two numbers? Are they prime numbers or composite numbers? So the answer is they are neither prime nor composite. So this is the key point of today, that 0 and 1 are neither prime nor composite numbers. Okay, why they are not prime numbers? Because prime numbers have at least two factors, and why they're not composite numbers? Because they're only one number, they don't have more than one factors. Okay, now coming to a bit higher concept that is called, to understand prime numbers, we're going to learn about square roots today. Okay, so can you tell me 5 times 5 is 25. So if we take the square root of 25, we will get 5, right? Similarly, 6 times 6 is 36. So if you take square root of 36, you get 6. Similarly, if you have 9, square root of 9, it is equal to 3. Square root of 16, it is equal to 4. But what about square root of 47? You can use your calculator to find the answer of square root of 47, because 47 is not a perfect square. You will get 6.9 in decimals for 47. So students, with the numbers that are not perfect squares are also called prime numbers, because we cannot find the perfect square root of 47. So 47 is a prime number. So square roots also help us find out the prime numbers, because the numbers which do not have any perfect square are also the prime numbers. Now let us find out about few numbers. Explain. Let me write 387 and 997. So 387, is it a prime number? No. Why? Because it is divisible by 1, 3, and many other numbers. What about 997? 997 is a prime number because it is not divisible by any number. Okay. We also need to study one thing that is called index notation. So what is index notation, kids? If I have written 5 times 5, can I write is 5 to the power 2? This is called index notation. If I write 5 times 5 times 5, can I write 5 to the power 3? This is called index notation. I can write 5 alone. Can I write 5 to the power 1? This is index notation. If I write 3 times 3 times 3 times 3 times 3 times 3, 1, 2, 3, 4, 5, 6. So can I write 3 to the power 6? This is called index notation. So this is how we can write the things in the index notation. We can do the prime factorizations and then write our solutions in the form of the index notation. So can everyone hear me and everything is clear up till now?
Excuse me.
Yes.
Yes.
Miss, I have one question.
Yes,
Miss?
yes. Yes.
Miss, you said that 47, we cannot find the perfect square root for 47, but how did the answer come in decimals?
This is not the perfect square root. We can find it with a, if you can press your calculator square root of 47, you will get a decimal answer 6.9. But if it is not 47, it is 49. It has a perfect square root, it is 7, because 7 square is 49. So we square root of every number exists. But if the square root is perfect, then it is not a prime number. If square root is not perfect, then it can be a prime number.
Okay.
Okay. Very good for your question. Nice question. Okay. Coming to the questions now. Determine whether each of the following is a prime or a composite number. So what about 87? Now everyone is going to answer one by one, and you people will take just a minute to answer. Okay.
I have a
I
question.
will ask you. Yes, Fajr.
Miss, when you were telling about the square root, the number, if the number can be divided by more than one, then like why did you write only one number?
Where?
Yes.
Here. See, I get the. I need to find out if 387 is a prime number or a composite number. So I know that 387 is can be divided by 1 and 3 and 387. So I get more than two factors, and my answer is yes, no, it is not a prime number. I do not need to find all of the prime factors, because the finding prime factors was not the question. The question was, is it a prime number or a composite number? So if I get one extra factor, it will help me tell if this is not a prime number, it is a composite number. Clear?
Yes, ma'am.
Okay. Okay, determine whether each of the following is a prime or a composite number. Yes, starting from Aisha, 87.
Prime number.
Okay. Next. Yes, Fajr, 67.
Miss, 67 is a composite number.
Why?
Miss, it's a prime number because it can only be divided by one in itself.
So who said that it is a composite number? Someone said that it is a composite number. Can the person explain me how?
Miss, it was me, but I didn't understand. Then I found.
Okay. So for 87, we are going to use the roots. For 87, check if 87 is divisible by 1. Yes. If it is 87 divisible by 2? No. Is 87 divisible by 3? Please check everyone.
No.
No.
Check everyone if it is divisible by 3 or not. Divide it by 3 if you don't know the rules.
Miss, it is.
Yes, it is divisible by 3. So we get more than one factors for 87. So 87 is a
87 is
composite.
a composite number.
Miss,
Composite.
29 times 3 is
Miss,
87.
3 multiplied by 29 is
Now
87.
67. Now tell me 67 is divisible by 1. So can you find any other number with which 67 is divisible apart from 67? No, so it is a prime number.
No.
Okay, 73. 73. What do you say about 73? It is divisible by 1 and
73.
Itself.
73.
so it is a prime number too. Okay, 91.
It
Composite.
can be divided by one
Why?
Composite number.
Why?
prime number.
Why
1,
composite?
7, 13.
1, 7. Because it is divisible by 7. Because 91, 7
Miss,
times 1 is 7. 7 times 3 is 21. So it can be divided by 7, 13, 21. So it is composite.
Composite number.
Miss, I didn't
I
quite
mean,
understand the 67. No, the 91 one. This one.
You cannot understand 91?
No, can you again tell?
Yes, tell.
Like how can we find out that how many factors that is it has?
We need to check each and every table to find out how many factors it have. Also, divisibility rules help us to find out. And we will revise the divisibility rules in one of our lists.
Okay.
Okay, now coming to question 2. If P and Q are whole numbers, such that P multiplied by Q is equal to 37. Find the value of P plus Q. We need to find P plus Q when P times Q is 37. Okay, so now we know what about 37. Is it a prime number or a composite number?
Miss, it is composite number.
Yes, Fatma, Rahman, Zain, please participate. Is it a prime number or a composite number?
Prime number. Prime
Very
number.
good. So if it is a prime number, it has only two factors. It is a product of two factors. It is 1 and 37, which is equal to 37. So it means value of P is 1 and value of Q is 37. Now our question is, what is P plus Q? So let's substitute the values. P is 1 plus Q is 37, which will be equal to 38. Got it?
Yes,
All
ma'am.
clear? Okay. If n is a whole number such that n times n plus 42 is a prime number, n times n plus 42 is a prime number. So if it is a prime number, we have to find n. Okay. Now 42 is not a prime number. What should I add in 42 so that it will become a prime number? Can I put n is equal to 1? Let's try. Let's try by putting n is equal to 1. 1 times 1 plus 42. 1 times 43. 43. Is 43 a prime number?
Yes.
Yes. So we get our answer. So what is the question saying? That n times n plus 42 is a prime number. They're saying it is a prime number. So we need to put the values of n to find out which prime number will work. We will start from n is equal to 1, and n is equal to 1 will give us the answer. Because after substituting n is equal to 1, we get 43, and 43 is a prime number. Our problem is solved. Okay. Coming to question number 4. Find the prime factorization of each of the following numbers. So prime factorization and leaving your answer in the index notation is something very simple, and you people already know how to do prime factorization. But I will do each and every step on the screen so you can cross check it. 72. So starting from the table of 2, 2 times 3 is 6. 1 carry, 6 is 12. 2 times 1 is 2. 1 carry, 8 is 16. 2 times
18.
9 is 18. 3 times 3 is 9. 3 times 1 is 3. So now we can write it in the form of index notation. How many times is 2 coming? 1, 2, 3. 2 times 2 times 2 times 3 times 3. So we can write 2, 1, 2, 3 times 3, 1, 2 here. Got it? Okay. 756. 2 times 3 is 6. 1 carry. 2 times 7 is 14. 1 carry, 8 is 16. 2 times 1 is 2. 2 times 8 is 16. 2 times 9 is 18. Now it is, can we move with 3, table of 3 times? 6 is 18, 3 is 9. 3 times 2 is 6, 1 is 3. 3 times 7 is 21, and 7 times 1 is 7. So now coming back to our purple color, we will write 2 times 2 times 3 times 3 times 3 times 7. So 2 square times 3 cube times 7. Okay. Next question is 187. Okay, what about the factors of 187? Should I start with 11? 11 times 1 is 11. I will carry 7. 11 times 7 is 77. And 17 times 1 is 7. So the prime factorization is 11 times 17. Next question, 630. 2 times 3 is 6. 2 times 1 is 2. And 5 is 10. And next we can do with 5. 5 times 6 is 30. 5 times 3 is 15. 3 times 2 is 6, 1 is 2. 3 times 7 is 21. 7 times 1 is 7. So we can write in the way 2 times, 5 times, 7 times. 3 is coming 2 times, so I am directly writing 3 square. Everyone is clear with all of the prime factorizations?
Yes.
Yes.
Okay, good.
Yes.
Coming to question number 5. Express 2026 as a product of its prime factors. Let's find out the prime factors for 2026. Okay. If the meeting goes end, you can join the meeting again. 2 times 1 is 2. What is this happening? 0, 1, 3. 1, 0, 1, 3. So 1, I don't think so. 1, 0, 1, 3 is a prime number and it cannot be divided further. So 1, 0, 1, 3 times 1. So you got 2 factors, 2 times 1, 0, 1, 3. Part 1 is done. This is part 1. Now, given that A and B are whole numbers, such that A is less than B. So they are saying A and B are two numbers, such that A should always be less than B. They are saying the condition A is less than B. And A cross B is 206. And when we multiply the two numbers A and B, we should get 2026. So write the possible pairs of A and B. So first of all, let's find the possible pairs. So 2 times 1013 will give you 2026. 1 times 2026 will give you 202. So you have only two options because they're saying A multiplied by B is equal to 2026. So you have two options that 2 multiplied by 1013 is 2026 and 1 multiplied by 2026 is 2026. Now we have to make the pairs in the form like this. That A should be less than B. First element should be less than the second element. So 2 is less than 1013. So the first pair is 21013. 1 is less than 2026, so 1, 2, 0. So this is all about this prime factorization and writing in the form of pairs, nothing else. It seems that this is a very difficult question, but this is yes, yes. Yes, what is your question?
Miss, I thought that A into B has a specific value.
A into B are the
Specific. Every letter has a specific value.
no. Basically, given that A and B are whole numbers, they can be any whole numbers. It is not a specific value. They're saying A and B can be any whole numbers, but the condition on A and B is that when we multiply the two whole numbers, we should get 2026. So there are only two cases in this world in which we will multiply the two whole numbers and we will get 2026. That is 2 multiplied by 1013, first case, and second case. Now these two cases, we can arrange them in this way and we will get our answers.
Okay, Miss.
Clear? Clear to everyone?
Yes.
Yes. Okay.
Yes.
Okay, question number 6. Charles uses 273 1 centimeter cubes to make a cuboid. Each side of the cuboid is longer than 1 centimeter. Find the dimensions of the cuboid. Okay, let's do the prime factorization for 270. Starting with 3. 3 into 91 will be 3 9s are 27. Okay, next we can do it with the table of 7. 7 times 1 is 7, 8, 9, 7 times 3 is 21, and 10, 13. So the question is, Chadel uses 273 1 centimeter cubes to make a cuboid. Each side of the cuboid is longer than 1 centimeter. So we need to find the dimensions of the cuboid. So 273 can be written as 3 into 7 into 13. So only possible dimensions can be 3 centimeter by 7 centimeter by 13 centimeter. This is the possible dimension. Prime factorization gives you the answer. Clear to everyone?
Yes.
Zain, are you getting the things? You're not participating?
Yes, miss.
Okay. Express 2026 as a product of its prime factors. So again, the things are becoming very easy for us because all of the students are very intelligent here. So we can easily do the prime factorization for 2026. 2 times 1 is 2, 0, 1 is 2, space 6. Is the question repeated? Yes. So we can skip this question because it is repeated mistakenly. Okay. 5 and 6 are done. Okay, 7. Find all the prime numbers in each of the following decades. A. Okay, is 2011 a prime number?
Yes, it's a prime number.
Yes.
So I will write all of the list. 2011, 12, 13,
Yes.
14, 15, 16, 17, 18, 19, 20. And now I will mark the prime numbers. And you are going to tell me. Yes, Harim,
Yes, miss.
which is the first prime number in this list?
2011.
Okay, which is the next prime number? Yes, Fajr.
Miss,
Yes,
2012 can be divided by 1, then 2.
yes.
Then when we get the number factorization, 2 times 10 is 20,
I'm
2 is 12.
yes, yes.
So 1,
So
6.
2012 is not a prime number, na? Tell me which is a prime number. Which in this list, which next number is a prime number?
1, 2, and 2012.
No. 2011 is a prime number. Now I have make a list over here. 2011, 12, 13, 14, 15. So which next number is a prime number? Okay, then.
2013.
Very good. See, Fajr, 2012 is not a prime number, so 2013 is a prime number. Okay, so can we have more prime numbers? Okay, are you sure about this that it is a prime number then?
Yes.
Yes, Fatima. Yes, Rehma, why are
Yes,
you not
miss.
participating?
Yes, miss.
Is 2013 a prime number? 2 plus 0 plus 1 plus 3. 2, 3, 4, 5, 6 results in 6. Means it is divisible by 3.
Ye-
So it is not a
Yes.
prime number. Not a prime number. Got it? We'll revise the divisibility rule. Hello students, can you hear me?
Yes.
Yes, ma'am.
So 2011 is a prime number and the next prime number is 2017. These are the two prime numbers here. Okay, coming to part B. From 2021 to 2030, what are the prime numbers? So let's just write 2021.
21.
2027.
So which is a prime number 2000
And 27. 2027.
and 2029. So I can fastly tell you that why others are not prime numbers. So this was not a prime number because it is divisible by 2. This is divisible by 3. This is divisible by 2. This is divisible by 5. Divisible by 3. Divisible by 2. Divisible by 9, 10, 11, 12, 3. Divisible by 2 and 5 both. So this is 2, 3, 4, 5. 2021. It is divisible by which number? 2021. 2021 is divisible by 7, maybe. Yes, students.
Miss.
Divisible by 43. Divisible by 2, 3, 4, 5, 6, 7. 2023. Yes.
Divisible by
Can it be divisible by 7? 2023. 2023 divisible by 7. Yes, divisible by 7. Divisible by 2, divisible by 5, divisible by 2 again, divisible by 2 again, divisible by 2. So these are all the reasons that why others are not prime factors, because prime numbers have only two factors, one in itself. So I have given you the reasons that why other numbers are not prime numbers. Okay. So question number 8, if A and B are whole numbers such that A cross B is 2027. Now the question says, listen to me carefully. One student. Okay. A cross B is equal to 2027. Okay. The question is this is given. We need to find out A plus B. Now we just find out 2027. 2027 was a prime number. It means it has only two factors, 1 and 2027. We just did it in the last question, right? So it means 2027 can be written as a product of two numbers. It is 1 times 2027, which is equal to 2027. So you can just mute your mic because few sounds are coming from your side. So 1 times 2027 is equal to 2027 because 2027 is a prime number. So what is A? A is 1. What is B? B is 2027. So now substituting in this A plus B. 1 plus 2027. So what you will get 1 plus 2027 is 2028, which is the answer of this question. Clear? These are very easy questions. Okay, find the prime factorization of each of the following, leaving your answers in the index notation. Again, prime factorization, you are going to help me
Wait,
to
Miss, can you
extend.
go up again?
Yes, I can go up again. Yes. Yes. What is your question?
Miss, I'm just writing it so I can explain it.
Okay, but did you understand everything?
Yeah.
Let me know once you are done. Done?
Yes.
Okay. Thank you. I will also share these notes in the group. Okay. Okay. So 8, 6, 2, 4. Starting from 2. 2 times 4 is 8. 3 is 6. 1 is 2. 2 is 4. 2 times 2 is 4. 1 is 2. 5 is 10. 6 is 12. 2 times 1 is 2. 0. 7 is 14. 8 is 16. 2 times 5 is 10. 3 is 6. 9 is 18. Okay, so now I have 539. Can I move with 7? 7 times 7 is 49. 50, 51, 52, 53, 4 carry. 7 times 7 is 49. 7 times 11 is 77 and 11 times 1 is 11. So when I write in the index notation now, we have already done the index notation. I'm doing it directly, okay? 1, 2, 3, 4. 4 times 2 times 7 is coming 2 times and 11 is coming only 1 time. So this is my answer. Okay. Part B, 6804. 2 times 3 is 6, 4 is 8, 0, 2 is 4. 2 times 1 is 2, 7 is 14, 0, 1 is 2. Okay, I have 1701. 3. 3 times 5 is 15, 16, 17, 2 carry. 6 is 18, 19, 22 carry. 3 times 7 is 21. Then I can again 3. 3 times 1 is 3, 8 is 24, 9 is 27. 6 is 18, 3 is 9, 2 is 6, 1 is 3, 3 7 is 21, 7 was 7. I am directly writing the index notation, students. 2 is coming 2 times, 3 is coming 1, 2, 3, 4, 5 times, and 7 is coming 1 time. Students, you can just stop me if you have any problem in the prime factorization part.
Okay.
Okay, so now see. Now this is 3 at the end and sum can be divisible by 3. Let's start with 3. 3 times 8 is 24. 3 times 7 is 21. 2 is 6. 1 is 3. 3 times 2 is 6. 9 is 27. Whenever you have to take two numbers together, you need to put 0. 3 times 7 is 21. Okay. Whenever you take two numbers together, you need to put 0. If you are taking two numbers together in the first place, like this, 3 times 8 is 24. You are not going to put any 0, or you can put 0 over it. But if you take any two numbers, at any part, you have to put 1 0. This is important. Okay. 3 times 8 is 24, 9 is 27. 2 carry 3 times 6 is 18. 19, 22 carry 5 is 9 is 27 again. And 3 times 3 is 9, 2 is 6, 3 is 9. And 3 times, no, not 3 times now. Now it is 323. So, students, can you check if 323 is divisible by 17?
Yes.
Yes. You can check if 323 is divisible by 17. So, we can write 3 to the power 1, 2, 3, 4 times 17 times 19. We're done with it. Okay. Last question. And I think it is a lengthy one. Maybe I get some space to solve. Okay. The question is 196000. Okay, 2 times 9 is 18. 19. 2 times 8 is 16. 2 times 4 is 8. 2 times 2 is 4. 2 times 4 is 8. 2 times 5 is 10. 0, 0. 2 times 1 is 2. 2 times 2 is 4. 2 times 2 is 4. 2 times 5 is 10. 0 again. 2 times 6 is 12. 1 is 2. 2 is 4. 5 is 10. So now we cannot further do it with 2. We need to do it with 5 now. So 5 times 1 is 5. 2 is 10. 2 is 10. 5 is 25. 5 times 2 is 10. 4 is 20. 5 is 25. 5 times 4 is 20. 4 carried 9 is 45. So we have 7 times 7 is 49. 7 times 1 is 7. So finally we ended up. So we have 2 to the power 1, 2, 3, 4, 5. Then I have 5 to the power 1, 2, and 3. And 7 to the power 2. So everyone done with this question? Can I move on?
Yes.
Very good.
Yes.
Okay. Question number 10. Given date x and y are the whole numbers, such that x is less than y and x cross y is 2022. Again, they are giving such type of questions that x multiplied by y is equal to 2022. So now, what are the possibilities? We need to find out 2022 prime factorization, and we will know the possibilities. 2 times 1 is 2011. 1011 is the possibility, and 3. 3 times 3 is 9, 10. 3 times 3 is 9, 10, 11. 3 times 7 is 21. And who is this again and again making disturbance?
I can't hear you.
Can 337 be divisible by any number? No. So 337 will come like this. Can you recheck if 337 is a prime number or not?
Prime number.
Yes, yes, it is a prime number. So what pairs did we get now? We get 1 times 2022 will give 2. Now we are going to write the pairs right over here. Okay, so 1 times 2022 is going to give 202. First option. Second option is 2 multiplied by 1011. 2 multiplied by 1011 will give you 202. Third option is 3 multiplied by 337. No, 3 times 2 is 6. 6 multiplied by 337 because the product will come over here. 6 times 337 will give you 2022. And 3 multiplied by, we can take the product like this, 337 by 2. So we can write 3 times 337 multiplied by 2 is 640, 674. Will give you 202. So let's see how did I make the pairs. First of all, I know 1 times 2022 is 2022. And then I can see 2 times 1011 will give you 2022. Now the product of these two, 3 into 2 is 6. So 6 times 337 will give you 2022. But if you need to take the product of these two, leave 3. Leave 3. 2 times 337 is 674. So 674 multiplied by 3 will give 202. And 6 times 337 will give you 20. So this is the way we find the options. So we get 4 options, and we can write the options in the form of ordered pair like this. 1, because they're asking in the form of ordered pair x comma y. 1 2022, 2 1011, 6 337, 3 674. This is just prime factorization, and after prime factorization we need to find out the pairs. Yes, is everything clear, students?
Yes. Yes.
Okay.
Yes.
Question number 11. Ali wants to use 2101 centimeter cube to make a cuboid such that each of its sides is longer than 1 centimeter. There are 6 possible cuboids that he can make. Find the dimensions of any 3 of them. Okay. So how we are going to do this one? Again, prime factorization will help us. Okay. So 210. Can we do the prime factorization with a table of 2 times 1 is 2, 0, 5 is 10. So first pair is 2 into 105. 2 into 105 is pair number 1. Next we 5, 6. So 3 times 3 is 9, 10, 3 times 5 is 15. And we get 35. So we can get the next pair 2 into 3 into 35. Okay, next 5 times 7 is 35. So we can get the next pair 2, 3, 5 into 7. So we get 2 times 3 into 5 into 7. Okay, next is 7 times. So we have already done 2, 3, 5, 7. So now we can make the pairs from all these pairs. Okay, so we have 2 into 105, this is the first pair. Then we have 2 into 3 into 35. Now can we make a new pair from here? 2 into 3 is 6, so we can write 6 into 35, or we can write 2 times 3 into 35 is 105, or we can write 3 times 35 multiplied by 2 is 70. So we can just multiply it with each other and get new pairs. Okay. So we can also write 3 into 5 for this one. We can also write 3 times 5 times 7 times 2 is 40. We can also write 3 times 7 times 5 into 2 is 10. We can also write 5 times 7 into 3 into 2 is 42. So these are all the possibilities. So we can write 5 times 3 into 2 is 6 into 7. So now we can product all of the numbers with each other and get the new possibilities. So all of these are the dimensions which are possible. All of these are possible dimensions. We just need to put centimeter. But they are saying write any 3 of them. So we are going to write any 3 of the dimensions. It will be our final answer. So we can write any 3 of them. We can write, for example, 2 centimeter, 3 centimeter, 35 centimeter. Number 1 possibility, number 2 possibility. For example, we can write this last one, 5, 6, and 7, 5 centimeter by 6 centimeter by 7 centimeter. For example, I can write one more. Which one should I write? I can write this 3, 5, and 14. Okay, so it's 3 centimeter by 5 centimeter by 14 centimeter. Done with it. Yes, students, did you understand?
Yes.
Coming to the last question. The last two questions are a bit of the advanced level, but I hope you are understanding them. Okay. So David uses 5041 centimeter cubes to make a cuboid. The perimeter of the top of the cuboid is 20 centimeter. Each side of the cuboid is longer than 2 centimeter. Find the possible height of the cuboid. So let the length of the cuboid is, let the length is equal to L, and let width is W, and height is H. So according to this, the perimeter of the top of the cuboid is 20 centimeters. So how to find the perimeter of the top of the cuboid? It is length into width, length into width, length plus width plus length plus width. So we can write 2L plus W, which is the perimeter of the top of the cuboid, which is equal to 20 centimeters. So we can write L plus W, which is equal to 10 centimeters. All clear up till now? Now, they said since each side of the cuboid is longer than 2 centimeters, each side is longer than 2 centimeters, we can consider the following possibilities. Now, what are the possibilities? We can write, because L plus W is equal to 10, so it can be 3 plus 7 is equal to 10, or 4 plus 6 is equal to 10, or 5 plus 5 is equal to 10. Now, we need to calculate the volume, because the question says volume 50 David uses 5041 centimeter cubes to make a cuboid. So it means it is the volume given. So we can find the volume. Volume is equal to length into width into height, which is equal to 504. So now we need to find H, because we already know L and W. So what? Because find the possible height, we need to find height. So can we write like this? Height is equal to 504 divided by L and W comes in the form of the real like this. Now, what are the possible heights possible? Possible heights. Okay. Now we have possible, students, you can see we have possible values of length and width. This is length and width, length and width, length and width. So taking the first possible value of length and width, that is 3 and 7. So if L is equal to 3 and W is equal to 7, so what will be the height? Height will be 504 divided by 3 times 7. What you will get? 24 centimeters. Now taking the second option, 4 and 6. Okay, if L is equal to 4, W is equal to 6, then what is the option? We get height is equal to 504, 4 times 6, which is equal to, yes, this is simple calculation, students, 21 centimeter. The last option, 5 plus 5. So if L is equal to 5 and W is equal to 5, so height is equal to 504, 5 times 5, which will be equal to 20.16. So 20.16 is not an integer. So what is the question saying? Find the possible height of the cube and it should be an integer. So we have only two possibilities. One is 24 centimeter and one is 21 centimeter, because this is the answer in decimals, which is not the possibility. So the possibilities of height are 24 centimeter and 21. Everything clear, students? Okay. Alhamdulillah, we have completed the exercise and also our lesson is up. So thank you so much for your time. Do the practice at your home on your own. The practice part is on your own. Okay. So you have to do the practice on your home. I will try to send you the recordings and the documents so that you can look after it if you need. Thank you so much, students. Take care. Allah Hafiz.
Okay, thank you. Please. Allah Hafiz.